So for some of the students out there, one of my students has asked me to do a few questions. I'm not sure which question you actually want me to do, but I can just do them all pretty fast. So this is mostly about inverses and just sketching them. Okay, so let's go. Sketch the function and the inverse function for f of x equals 2x minus 8. So we draw our axes. Okay, now we choose a point here. So we'll say we know that I'm going to sketch the main function first. So this will be minus 8. Where will it hit? The gradient should be 2, because that's 2 there. So it shouldn't be, like if I was drawing like y equals x, which is going to be my dotted line later. I'll draw it in now. The gradient is 1x, but this is 2x. Gradient equals 2. So it's going to be more steep than this. It's more going to be like something like that. Okay. And also we know that this point is going to be 4, because if 0 equals 2x minus 8, this is the x-intercept. So we set y 0, then x equals 4. Okay. So if that's 8, this should be 4. Okay, so the inverse is going to be the mirror image. So a little secret trick I like to do is kind of just draw the mirror image like this. I'm going to go through here. I'm going to go through here. There. This equation will be f of x equals 2x minus 8. Now let's figure out what the inverse function is. So to figure out the inverse, we just swap x and y around. Essentially that makes turn the y to x and the x into y. And now we want to rearrange it to make it y the subject again. X plus 8 equals 2y. Y equals, both sides by 2. X plus 8 on 2. X plus 8 on 2. And that'll be 4, because it's mirrored. And that'll be minus 8. Yeah, so when x is minus 8, y equals 0. Perfect. Find the point of intersection. Point of intersection is when we make those two functions equal. So x plus 8 on 2 equals 2x minus 8. Or x plus 8 equals, multiply both sides by 2, 4x minus 16. Or, so I bring all the x's to one side, 3x equals, I brought the x over, I bring this stuff over, 16 plus 8, 24. X equals 8. This will be 8. Now we need to find the y, so we just sub in 8 in here. But we know it's going to be 8, 8, because the intersection of inverses always has the same x and y coordinate. But we just sub it in. 8 times 2, 16 minus 8 gives us 8. Done. Okay. So let's look at this one. So they've restricted the domain from 0 to infinity. 0 to infinity, including 0. So we have to do a black dot. And our graph of x squared looks like this. Okay? And now if we do our dotted line, our inverse will look like that. So x squared. Good. And this is 0. So let's find the inverse. X equals y squared. Y equals square root of x. So this would be square root of x. This is what they both look like. How do we find the points of intersection? Well, we just let them equal each other. Square root of x equals x squared. It's the best way to go from here. Okay, then this becomes x to the half equals x squared. 0 equals x squared minus x to the half equals x to the half 3 on 2 minus 1. So either this equals 0, which implies x equals 0, or this thing equals 0. Because if this entire thing equals 0, either one of these two has to equal 0. This equals 0, implies x equals 0. This equals 0, implies x to the 3 on 2 minus 1 equals 0. Or x to the 3 on 2 equals 1, or x equals 1. So the 2 points are 0, 0. I sub that in 0, 0, or 1, 1. Right. And finally, this question. F of x equals ax plus b f of 1 is 4, the inverse of 1 equals 6. So first we need to find the inverse function, so to find a and b. Otherwise we can't use these bits of information. Like we want to use these, I can use that. I sub 1 as x, and then I get a plus b equals 4. But I can't use this one yet. So let's try it. X equals ay plus b, x minus b equals ay, y equals x minus b on a, and that's our inverse function. Then we replace it again, x minus b on a. So now we can use our two bits of information. 1 tells us that a plus b equals 4. 2 tells us that 1 minus b on a equals 6. I'm just subbing 1 as x. So we can make this simpler. 1 minus b equals 6a. Okay? Or I can rearrange that to go 1 minus 6a equals b. And I'll call this 3. So now I have b. Like, how do you solve two equations? You have to get rid of one of the unknowns. There's two equations, two variables. You have to get rid of one of these variables. So I can get rid of b by subbing it into there. And we sub 3 into 1. And you get a plus 1 minus 6a equals 4. Or minus 3 equals 7, equals 5a. I shouldn't jump too many steps, but it's a minus 5a, and 6a gives us 5a. Actually, I won't jump all the steps. Minus 5a equals 3, for a equals minus 3 on 5. Minus 5a, take the 1 over 3, divide by minus 5, a equals minus 3 on 5. And now we just sub it back into here. 1 minus 6 times minus 3 on 5 equals b. b equals, 2 minuses become a plus, 1 plus 18 on 5. 6 times 3 gives 18, divided by 5. b, I don't like using these partial fractions. I like to make them all improper. So we go 1 times 5 makes 5 plus 18. I'll show you 5 on 5 plus 18 on 5 equals 23 on 5, because I know a lot of people have problems with fractions. b is 23 on 5, a is minus 3 on 5. Have a quick check. A plus b equals 4, so 20 on 4. A plus b, yep, 20 on 4, that's 4. And f of dash minus 1 equals 6. So, inverse function is here. So we put 1, and we get 1 minus 23 on 5, which becomes minus 18 on 5, divided by minus 3 on 5, and that becomes 18. Awesome. 18 on 3, which becomes 6. You don't need to do the checking part, but I just like to check quickly. So that's how you do inverses. Is a graph of the inverse, just pretty simple graphs, and a fairly simple question involving inverses and how to use bits of information. Great. Have a great night.